Okay, so I have two problems that she gave me, and we'll start with this one. So it's asking us to calculate the I, V, and P of the circuit. So this is our circuit here. And then it's asking us to fill in the table. So we'll go ahead and start with collapsing the circuit. Do you guys want me to give you some time to like try and work it out on yourself first, or do you want me to just like go jump into it? Okay, I'm gonna just go into it then. So first collapse you can see will be, oh, that is thick. Will be this R1 and 2. And then probably our second collapse is gonna end up being those three. So R1, 2, and 4. And then the final collapse will be all of them together. So R1, 2, 3, 4. So we'll start with R1 and 2. We know that this is resistors. So resistors, they add up in series. Here, I have a table over here. This is from a past supplemental, but we made this table and we noted that, okay, resistors are the opposite of capacitors, because when you add up resistors in series, you add them up normally, versus when you add up capacitors in series, you add them up in their fraction version. So we're gonna go ahead and go add those resistors just normally. So that's gonna be R1 plus R2. Our R's are given up there. So 1, 2 is equal to R1 plus R2 is equal to 2. Units for resistors, I believe should be ohm. I'm gonna go ahead and put ohm. And then I'll write that up here. 2 is 5. So that's gonna be 5, 6, 7. It's gonna be 7. I'll go ahead and write that in here just because I like to keep track of it. And then our second one is R1, 2 and R4 in parallel. Hey Celeste.
I don't know why. I was like, oh, I don't see it.
Let me get this up on the podium. I honestly didn't think anyone would show up in person.
Yeah, well, I was like,
Wait, you were online?
like earlier for like a few seconds.
Wait, which one?
The one I used like for Friday.
Oh no, I'm just using my Dr. C should have sent it out. It's my office hours link.
I have to check.
Okay.
That's on that one. I was like, let me just check you first.
Yeah, okay. Sorry.
You did.
You guys, I'm gonna go ahead and pause the recording while I set this up. You guys continue and try and solve the problem. Okay, one more time for the recording. My bad. We just finished collapsing the circuits, so R1 and 2 series, so we add regularly. R1, 2, and 4 are in parallel, so we add them with their fractions, and then we've multiplied by like technically 1, but 2 over 2 and 7 over 7. So they're easy to calculate. And we calculated the R1, 2, 4. And then R1, 2, 4 and R3 are in series, so we add them regularly. And then I'm just gonna go ahead and move the work so we have some room. Ah, shoot, I moved the whites. That's the key, I think. Is that the key? Shouldn't be the key if that's, oh, it's not. It's for later. Okay. Now we've got the resistors, and now we can go ahead and start solving for things. So we have these equations up here, the I equals VR, and the P equals IV. I think we'll mostly be dealing with the I equals VR. Or technically V equals IR, and then you rearrange it, but either one works. And then we also can note that the battery provides 12 volts, which means that all the voltage running through all of these together should also be 12 volts. And we know that resistors that are in series have different volts, but when they're in parallel, they have the same volts. So when we collapsed our 1, 2, and 4, those two should have the same volts, and then we really only need to look at, got a different color, this one for the volts. So the total volts, 12 volts, should equal the sum of the voltage running through those two. So V3 and V1, 2, 4. And we can probably double check because that's what the key should be saying. She did it a few different ways. She went R3 and 4, have 12 volts. Or 3 and 1, 2. Oh, okay, I see what she did. I'll leave that out. So what she did was she did like this, where she grabbed just one or the top or the bottom, because these two, the 1, 2, and 4 should have the same voltage, so it's kind of like it's working the same way. So we'll probably stick with this R3 and R4. Just because there's a bit less there. I'm also gonna go ahead and change the screen to like red so we can see it a bit better. No, go ahead and move. So I guess we just have to pick one to start. I feel like R3 might be a good one to start. Mm. We have the R and we have the V. We can calculate for the V on R3, then we should be good. Is there a way to relate the I's? In series, they have the same I. Oh, in series, they have the same I. Okay, that works. So then we can calculate the I, 1, 2, 3, 4 which should be, because they're in series, the same as I3, which should be the same as I1, 2, 4. So then we have we're not using P yet, are we? We're using B. We have our V equals IR, because this is essentially all of them, all of the resistors. So V is equal to 12 volts. And then we're calculating for our R, and we're calculating for our I, and we have our R. So V, I'm just gonna write total is equal to I total, R total. Your I1, 2, 3, 4, which is our I total, is 12 volts divided by, what do we get for that one? Looks like 8.6 ohms. Go ahead and input that. 1.39. We're gonna double check our units right now, because I just like to, because yeah. I'm gonna just take it to the next page. Okay, so I have some of our common values up here. So in this case, we're gonna be using this one. The ohm is equal to V over A. So we have V over V over A, which you can rewrite as V over 1 over V over A in order to like kind of combine the fractions. So that gets us VA over V, which gets us A, which makes sense because our units are in amperes, so it makes sense. And then because we know that these are in series, then that is also our value for I3. So we can go ahead and write that into our table. This is 1, 2, 3, 4. And I3, which is amperes, is 1.39 ampere. Cool. We'll go ahead and move this up. And then we can probably solve for the V running through 3 at that point. Because if we look back at the table, resistors in series have different V's. So we can go I V3 is equal to I3 R3, which we have both of those, so we can just go ahead and plug that in. It's equal to 1.39 ampere and 7 ohm. We saw earlier that ohm is V over A. So it looks like our units are going to check out, right? Because V over A times A, the A is going to multiply out and you're going to get V. And so you get V3 is equal to, let me plug it in. 9, 7, maybe 1.3 volts. we can go ahead and write that into our table. 9.73 volts. Still recording. Might even be able to solve power for 3 at this point. Let's see. P is equal to. Yeah, it looks like we will be able to. Because our equation for that is P is equal to IV. So we can go P3 is equal to I3V3. We can plug in. I do not give myself enough room. $9.73 volts. It's just P3 is equal to 13.5. It's ampere times voltage. I'm thinking it's probably gonna be joules, but we'll double check. We have ampere, volts. Ampere is coulombs per second. And volts is joules per coulomb. So this is coulombs per second, and this one is joules per coulomb. So that's gonna get us joules per second. Okay. Yeah, that makes sense because it's work. I believe that should just be work. Oh shoot. I see that the Zoom will be ending in 10 minutes. Once the Zoom ends, we'll just meet back here again. So I'm just gonna keep going until the time's almost out, and then find a good stopping point, and we'll regroup. Anyway, we have work. We have 13.5 watts. And now we could probably solve for one of the other R's or I's. Probably one of these two in the 1, 2, 4. We know that they're in parallel, and according to resistors in parallel, they have the same voltage but different I's, which means that our voltage that we found up here of, did we find voltage for that yet? We have not. Okay. So we have our I 1, 2, 3, 4, which is the same as our I 1, 2, 4. So we'll start with that. I 1, 2, 4. So we're going to be solving for the voltage of 1, 2, 4 with the resistance of 1, 2, 4. So we have both these two. Our I is up here. It's the same one that we solved for at the beginning, because they are all related to each other. So that's going to be 1.39 ampere. And then the resistor value was 1.6 ohms. A124, 1.39 times 1.6. Still have 7 minutes. It's gonna give us, well, I got 2.2-ish. That sounds about right. And because we know that 1, 2, and 4 are in series, they have, sorry, parallel, they have the same volts. So that means that voltage of 1, 2, 4 is equal to voltage of 4 and voltage of 1, 2. So we can go ahead and write the voltage of 4 up here now, 2.2 volts. And then we can continue with using the voltage of 4 to find the other values for 4. And draw a line here. 4 is equal to I of 4 and R of 4. We have the V and R, so we're just solving for I. That's gonna go ahead and get us 2.2 volts over 2 ohm, which is probably gonna be 1.1, but I'm still gonna plug into my calculator. Yeah, 1.1 ampere. Right, because V over A, yeah, cool. That's gonna go, I put the wrong unit here. It's gonna go right here. I just, oh, shoot. At least we know we were right. It was 1.1A. I don't know if I can just grab that by itself. Okay. Wow. Oh, we'll just leave it uncovered. We know that we solved for that. Cool. And then we can solve for power there. So if I have room, our P of 4 is going to equal our I4 times V4, which we have both of those up there. So P of 4 is equal to 1.1A and voltage, which is 2.2. So that got us 2.42 watts. Cool. So I feel like this is a good pausing point, and I'm gonna go ahead and we'll move this stuff over, but also pause the recording and let the meeting time out. And then once you guys get logged off, just come back on. Sound good?